Welcome to my quiz. Question 1. Which of the sequences below begins with these numbers and has 256 as its 10th term? Here are your options. Well, 31 is not a power of 2, and 256 is the 9th term in the sequence of powers of 2 beginning at 1. So the answer is A. Moses' circle problem asks, if I put n points on a circle and join all the points, what's the largest possible number of regions that this divides the circle into? Here's a formula for the answer. By the way, it's the same as the answer to how many regions can I divide 4-dimensional space into using n-1 3-dimensional hyperplanes. It's the unique fourth-order polynomial sequence whose first 5 terms are 1, 2, 4, 8, and 16, and here's the graph of that polynomial. Question 2. Which of the equations below has the graph shown? Here are your options. The graph of an equation in variables x and y means by definition the set of all points in the xy plane whose coordinates x and y make the equation a true statement. In our case, when x is 0, there are a range of different y values that make our equation a true statement. Therefore, our equation cannot be a or b, and so the answer must be C. Please note that the graph of a discontinuous function does not include a vertical line where the discontinuity is. Question 3. Complete the sentence. A paradox means... Here are your options. The answer is C. In the word paradox, the para has the idea of contrary to, and the dox carries the idea of what one would think to be the case. Question 4. Which of the following claims about positive integers holds at least for the positive integers up to 10 quadrillion, but is known to ultimately be false? Here are your options. The answer is B, the Merton's conjecture. This is the claim that if I consider the integers going from 1 up to a number n, and I count how many of these can be expressed as the product of an even number of distinct prime numbers, and then I count how many of these can be expressed as the product of an odd number of distinct prime numbers, and then I take the difference between the two, this difference comes to at most the square root of n. It was conjectured in the late 19th century, and has been verified to hold for all n up to 10 quadrillion, but in 1985 it was proved that there must exist infinitely many values of n for which it fails. Nevertheless, there's a weaker version of the problem that still remains open, and that is it true that for every exponent strictly greater than a half, taking sufficiently large n guarantees this weaker version of the inequality, where the threshold for sufficiently large n can depend on alpha? If someone manages to solve this problem, they'll be awarded $1 million, because this is one of the many equivalent formulations of the Riemann hypothesis. Question 5. A conveyor belt is moving horizontally at a constant speed of 2 meters per second, while sand is being released onto the conveyor belt at a rate of 1 kilogram per second. How much power needs to be supplied to the conveyor belt to maintain this? Here are your options. I'm going to present two methods for this. For convenience, vectors in the direction of the conveyor belt's motion will be positive values, and vectors in the opposite direction will be negative values. A version of Newton's second law gives that the force of the conveyor belt on the sand is the rate at which momentum is being transferred into the sand, which comes to 2 newtons. By Newton's third law, the force of the sand on the conveyor belt is then minus 2 newtons, and so by Newton's first law, the force that we need to apply is 2 newtons. We multiply this by the velocity of the belt to get the power, which comes to 4 watts. The second method is that the power is the rate at which sand gains kinetic energy, plus the rate at which energy is dissipated in the contact between the belt and the sand. But the latter term is the rate at which sand is losing kinetic energy in the reference frame of the belt. Each of these terms comes to 2 watts, making a total of 4 watts. So the answer is C. Question 6. Is there a decimal expression that comes next after firstly 0.3 recurring and secondly 0.9 recurring in the lexicographical order? Lexicographical order basically means dictionary order, except here with digits in place of letters. Although a decimal expression has infinitely many digits, if we count terminations representing an infinite string of zeros, nevertheless, no individual digit in the decimal expression can occupy a position lying infinitely many decimal places to the right of the decimal point. Therefore, in the lexicographical order, the next decimal expression after 0.9 recurring is 1.0 recurring. However, if you take any decimal expression that comes later than 0.3 recurring in the lexicographical order, then there must exist other decimal expressions that lie in between the two in the lexicographical order, and so, in the lexicographical order, there's no decimal expression that comes next after 0.3 recurring, so the answer is C. Please note that although the expression 0.9 recurring and the expression 1.0 recurring are different expressions, just like the expression 0.5 and the expression 1 divided by 2 are different expressions, nevertheless the two expressions evaluate to exactly the same numerical value. Question 7. How fast are we moving through space? Here are your options. In day-to-day life, we define locations relative to things that we perceive as being fixed, such as roads, buildings, etc. When you arrange a rendezvous with a friend, you need to arrange a location in space-time for your meeting. You might do this by first fixing the location of where you're meeting, for example, outside the post office, and then later deciding upon a time. But at some point in your education, you probably learned that the Earth is actually spinning on its axis, and orbiting the Sun, and the Sun is orbiting the centre of our galaxy, and so on and so forth, so that in reality, outside the post office is not a fixed location. But when we learn this, we still mistakenly project our localized way of thinking onto the whole universe, and imagine that the universe itself still has fixed spatial locations, even if no hard object in the universe is staying fixed over time at one of those locations. But this has no justification. If two events take place at different times, how can you define a concept of whether or not they took place at the same spatial location in the universe? So the question of how quickly we're going from one location in space to another makes no sense, so the answer is D. Question 8. According to the Desmos scientific calculator, -1 squared is equal to 1, but -1 to the power 2 and a bit is undefined, except when I fine-tune the decimal to make the answer something else. What is that something else in this case? Here are your options. There's no glitch here, and the answer's not infinity. Option B is what Desmos gives when you turn on complex mode, but in that setting it doesn't give undefined in the previous cases, so the answer is A. The convention that's being used here for raising negative numbers to non-integer powers is the natural convention to use in the context of describing relationships between real valued variables, so it's no surprise that it's the default setting for a graphing software like Desmos. I plan to discuss the details in a future video on 0 to the power 0. Incidentally, if I try and have more decimal places, Desmos can run into floating point errors. Question 9. Into a water tank of horizontal cross-sectional area 10 square decimeters is placed a 10 kilogram block of wood of horizontal cross-sectional area 9.5 square decimeters. What's the rise in water level? Here are your options. If convenient, please pause the video and share your solution in the comments. By Newton's first law, the upthrust force exerted by the water on the block balances out the block's weight. A corollary of Archimedes' Principle of buoyancy gives that the upthrust force is equal to the weight of water that would fill the volume of the container between the original and the new water level. So that's the volume times the density of water times the gravitational field strength. And now equating the two expressions for the upthrust force, we get that x is equal to 1, so the answer is A. Question 10. If a probability distribution is known to be perfectly symmetrical about some unknown value c, can we necessarily estimate the value of c by just taking the mean of a sufficiently large simple random sample? The answer is not necessarily. When the expected value formula gives a well-defined value, such as in the case of a normal distribution, then, by symmetry, that value must be equal to c and the procedure is valid. But when the expected value formula gives a competing positive infinity contribution and a negative infinity contribution, such as in the case of a Lorentz distribution, then the procedure can be invalid due to a phenomenon where taking a large random sample will have a high likelihood of including extreme values in your sample that skew the mean away from C. In fact, the Lorentz distribution has the bizarre property that taking a simple random sample of any size and finding the mean is mathematically the same as just taking a sample of size 1. Question 11. In the work on floating bodies in which Archimedes derived his famous law of buoyancy, what shape did he state that the surface of a body of water forms when that body of water is at rest? Here are your options. The answer is B. The surface forms part of a sphere that's concentric with the sphere of the Earth. We're used to the idea that the surface of a body of water at rest lies along a flat plane perpendicular to the direction of gravity, so that every point along the water's surface lies at the same height above the ground. But this statement presupposes that the direction of gravity itself is the same throughout the space that's occupied by the body of water, which is fine on the spatial scales that we deal with in day-to-day life, where we can basically treat the Earth as being flat. But when Archimedes was building the theory of hydrostatics, it seems he wanted his theory to be applicable not just to small bodies of water, but also to the vast expanses of water that cover much of the globe, and so he couldn't assume a flat Earth. And if you make certain idealized approximations, including that the Earth is a sphere with radially symmetric distribution of mass, then it's still true that all the points along the surface of a body of water at rest lie at the same height above the Earth, but this height is now measured radially from the centre of the Earth. Question 12. While keeping the same pitch, a person's voice sounds deeper when they... Here are your options. The answer is B. The sensation of how deep a voice is perceived to be comes not only from how low the pitch is, but also from how deep the tone colour sounds. The pitch corresponds physically to the fundamental frequency of the air pressure oscillations, and this is controlled by varying the length of the vocal cords. The tone colour is based on the relative strengths of the overtone frequencies and the air pressure oscillations, and while there are lots of factors that control this, the one that's most responsible for controlling how deep the tone colour sounds is the height of the larynx within the neck. The larynx is also known as the voice box, and particularly in males it can often be seen slightly projecting out from the neck. Inside the larynx lie the vocal cords. The most relaxed position of the larynx is lower for lower pitches and higher for higher pitches, and having the larynx in its most relaxed position will maintain a fairly similar tone colour across a range of pitches, while the other vocal parameters are kept constant.
Hello there. Hello there. Hello there. Hello there.
Question 13. True or false? The multiplicative inverse of 0 is infinity. The number 1 is called the multiplicative identity, basically because multiplying 1 by any number leaves that number identical. A multiplicative inverse of a number means an object whose product with that number is the multiplicative identity 1. If we pretend that we have an object that's a multiplicative inverse of 0, then we get that 2 is equal to 2 times the product of 0 and its multiplicative inverse. But we also get that 1 is equal to the product of 2 times 0 and the multiplicative inverse of 0, which means that these two terms cannot be equated with each other. This would have to be a very mathematically unnatural definition of multiplication, so we can say that the statement is false. If we want to define a mathematically natural extension of the concept of reciprocals to allow for a reciprocal of 0, our definition of reciprocal will probably have to be something different from the multiplicative inverse. The trick will be to define reciprocation in terms of geometry rather than conventional arithmetic, and I hope to discuss this as part of a future series of videos on infinity. Question 14. Complete the sentence. If all the DNA of all living humans were laid out end to end, the total distance that it would stretch would be of the order of 10 million... Here are your options. The architectural information of a biological organism is encoded within that organism's DNA. Copies of this molecule can be found in pretty much every cell of the organism. If you were to take all the DNA in one human and lay it out end to end, the total length would most likely be well over 100 astronomical units. For all living humans taken together, this comes to about 10 million light years. Incidentally, the total length of DNA in all bacteria on Earth might well be of the order of 500 billion light years. Question 15. A frictionless container has horizontal cross-sections of area 1 square centimetre above a certain point and 1 square decimetre below that point. The lower inner surface of the container, shown in red, is not fixed in place but rather is supported by a compressible layer obeying Hooke's law with a spring constant of 10 kilograms weight per centimetre. In the natural state, this lower inner surface lies 1 centimetre below where the container changes its cross-section. The question is, how much water would I need to pour into the container for the lower inner surface to go down by 1 centimetre? Here are your options. Please pause the video and have a go. Note that these parts of the container are pushing down on the water, since if they weren't present, then water would flow out. So the answer is less than 10 kilograms. By Newton's first law, the force exerted on the lower inner surface by the compressible layer balances out the force exerted on it by the water. The former is equal to 10 kilograms weight, and the latter is equal to the area times the water pressure, and the water pressure itself is given by the formula ρgh. So we get this expression. Equating the two forces gives the value of h and hence the volume of water, leading to the answer A. And indeed, with 298 grams of water, the amount of compression that minimizes the total potential energy of the system is 1 centimetre. Bonus question. A person dies owing debts to 5 creditors as shown. How should the person's wealth be distributed among the creditors? Considering 2 different hypothetical figures for the person's available wealth, here are 4 options. Pause the video and see if you can work out what's going on in each option. In A, every dollar of debt is repaid the same fraction of a dollar. In B, we seek to divide the available wealth equally among the creditors within the constraint that no creditor receives more than they're owed. In other words, it's as if we cycle through the 5 creditors, paying back $1 at a time, but remove each creditor from the cycle when that creditor has been fully repaid. In C, it's the creditor's losses that we seek to divide equally among the creditors, within the constraint that no creditor pays extra money to the other creditors. And indeed, we either seek to divide the available wealth equally, or divide the losses equally, within the respective constraint that either no creditor is repaid more than half the amount that they're owed, or every creditor is repaid at least half the amount that they're owed. Well, what's fairest will depend on your philosophy of fairness, but there are philosophies of fairness in which D is the unique fair approach. This may well be what was practiced among some ancient Jewish communities, and was only rediscovered relatively recently.